Conk Ingress Controller provides a Kubernetes native way to deploy and configure Conk inside Kubernetes. And previously, in order to scale this deployment, you have to have a lot of manual stuff to do this. With Conk Ingress Controller 2.9, we introduced new powerful feature called Gateway Discovery that drastically simplifies the way how you can independently scale those components, including controller and gateway itself. And let me show you how. Previously, if you wanted to deploy Conk Ingress Controller, you deploy a pod that includes controller and data plane. Data plane is our Conk gateway, and the controller is Conk Ingress Controller. With new feature introduced in Conk Ingress Controller 2.9, those deployments can be now separated. So your controller can be scaled independently in order to provide a resiliency for your configuration, and Conk data plane, Conk gateway, can also be scaled independently in order to provide you load balancing capabilities. So let's take a look how we can use this new powerful feature. On top, I have a Kubernetes client called K9S is up and running, watching for my Kik namespace. And here I'm going to deploy two things. I'm going to deploy Conk gateway, going to deploy a controller. I will scale this, we'll deploy app and see how this will work together. So first thing that we're using Helm to install only Conk gateway pods. So we disable usage of Conk Ingress Controller, and we enabling usage of admin API in order to controller access to this. We will wait few seconds until our Kubernetes cluster will provision an external IP address for my Conk gateway. As you can see here, IP address was provisioned. And we also successfully access to Conk. It's the latest and greatest version of Conk is running. So next thing is that we're using Helm chart to deploy controller separately. Conk Ingress Controller enable true. And we also enable thing called Gateway Discovery enables true. With this, we need to also specify the admin API for this service. So in this particular case, it's giving Gateway Conk admin service that Ingress Controller will be using in order to submit configuration. And this deployment will not include Conk. So there's will be two deployments for controller and gateway. Conk gateway, 2 replicas, and controller. Conk Ingress Controller, 2 replicas. Next step, we're gonna scale those. So what we're going to do, we're using the Kubernetes scale deployment for gateway with 4 replicas. And we're going to scale controller deployment with 3 replicas. We will wait until condition will be fulfilled. And after that, we bounce. And on top of this, we can see that our deployment will be scaling 3 replicas for controller and 4 replicas for Conk gateway. As we can see here, this instance of Ingress Controller will be a leader, so it will be talking to configuration. And as we can see here, this configuration successfully get access to data plane with address 31, 48, 29, and 32. So our Ingress Controller now will be able to send configuration to all 4 instances of Conk. So let's deploy some demo application and see how it works. Successfully, service was created and configuration was invalidated for our Conk gateways. Now let's use curl, and I will change the IP address with actual valid IP address of my external Conk. One of the things that we can notice that there's when I'm using HTTP and anything, it also includes the origin information, where this request is coming from. So this request is coming from this address, from inside of Kubernetes cluster. If I keep calling this, I will see this address will be different because those things would be load balanced. So now this address will be always different because those URL, those addresses will be rolling because we have 4 instances of Kong running. Hopefully this information was useful. Stay tuned for new updates about Kong Ingress Controller, and you can find this demo that you can play around in a GitHub and Kong in the demo scene. Take care.